Most people think cel shading in Blender is just this. Shader to RGB, color ramp, done. And yes, that works, but it's also the most limited way to do it. Cel shading in Blender can actually be far more powerful, fully interactive with light, highly customizable, and capable of producing professional anime style shading. In this video, I'll show you several techniques that almost nobody talks about that will give you far more control over your stylized lighting. And at the end, I'll show you a bonus technique that even works in cycles, which is really magical. So let's dive in. Cel shading is one of the most important techniques for creating anime style visuals in Blender, but most tutorials only show the simplest method. Today, I'll show you several powerful approaches used to create stylized lighting that reacts properly with your scene. Before we jump into the techniques, I should mention that the complete pack containing all of these cel shaders is available on my Patreon. You can simply type mix3ddesign.com or click in the link in the description and it will redirect you to my Patreon page where you can download everything used in this video. The membership is really affordable and it's a great way to support the channel if you want to see more tutorials like these. There is also a lot of additional content available right there. For example, KumoGen, which is a procedural anime cloud generator for Blender. It includes more than 100 different cloud shapes and it is extremely fast and customizable. Instead of modeling clouds manually or building complicated shaders, you can generate them instantly with just a few controls. And another update is coming very soon that will introduce a completely new cloud generation system. So if you want access to all of these shaders too and future updates, you can check it out at mix3ddesign.com. Your support really helps me continue making these tutorials like this one. Now, let's start by looking at the first cel shading technique. Let's take a look at the Eevee supported ones. These are supported mainly by Eevee. Okay, let's start with the first one. And by the way, they're available in the Assets Manager. So you can just select whatever shader that you like, drag and drop it into your object, and it's going to apply as easy as that. And you can control it however you want in the shader editor. If you want to go to the shader editor, you can control it. So the first one, if I select it, if I select the torus or the donut, whatever you want to call it, okay? So I'm going to explain to you how does that shader works, okay? By simple, stuff, okay? So basically, I'm going to take the diffuse. So the diffuse PSDF contains color data, roughness data, normal data. For us in MPR or cel shading, we care only about color data. Sometimes we need normals to distort kind of something or distort light or distort how shapes are going to be. But for now, we need a clean MPR or cel shading, okay? To do that, I need to separate the color data from all of these other kind of data, roughness and normal. So for doing that, I need to use the shader to RGB node. We're still going to use this one, okay? And it's going to output a color and also alpha. We don't need alpha for now, we need only color. And this color too has more details that we already know. It contains RGB for red, green, and blue, and also contains luminosity or value. So let's see how we can access those values. To access them, just simply connect the shader to RGB to a separate color. The separate color node has 3 modes. The first one and the easiest one is RGB, red, green, blue. Okay, that's it. But we don't need this one because this one is not meant for creating cel shaders. We need either one of these, HSV, which is standing for hue, saturation, value, or HSL, which is standing for hue, saturation, and lightness. Okay, lightness and value, both of them contributing into light. Okay, so basically, I want how light is going to travel from the light source like bouncing through all of these faces. I want this travel to be sharp, okay, with steps, with multiple steps. So the light is going to travel with each step, like brightest step, medium brightness, and really dark. Okay, to do that, I can take either the lightness. So basically you need the separate color and combined color to work with the same modes. So HSV with HSV, HSL with HSL. If you do HSV with HSL, that doesn't work. So please don't play with our minds. Use the same mode. So HSV for now, okay? And you can use HSL, it's up to you. And for that, I need to control how the value or the light, okay? Call it light. This value is light. I need to control this light and make it sharp. I want sharp lighting instead of soft lighting. Okay, so to do that, I'm going to use float curve with a stepped interpolation. Like I'm snapping from this value to this value without any in-betweens. So that's how we can create that sharp interpolation. So, and that will create this. Look at that. Okay, it is super. It's super sharp. This is just the shadow of this one. Okay. If I just move it, you can see this is the shadow. We still have the interactivity with the shadow and also with colored light. Okay, so let's select this back. As you can see, we have color, we have light, and we have shadow. And far beyond that, we can also use this this simple node, and that will create the same thing. Okay, the same thing, because the RGB curves contains RGB and also lightness or values. That's what the C stand for. The C stand for everything. So this is combined channels. So we have red, green, blue, and also behind the scenes we have lightness, and that create this. Look at that. It is the same thing. I just played with these points. Basically, these points make the scene or the shadow really dark or not really dark. You can control it. Okay, so basically it goes from 0 to 1. So 0 is black and 1 is white. Okay, so you can just play with these, you know, at any point that you like. And after that, I just took the Fresnel node, and this Fresnel basically just added outlines. It's kind of something like a personal preference that you like. Now let's move on to the second one. The second one where I want to have more control. And in this one, I'm going to introduce a new node. Okay, this node that only works in cycles, but with a bug or somehow it works in Eevee. Okay, it's a bug. It's really a bug, but it works in Eevee. Oh my god, it works in Eevee. Okay, let me show you. This node is called the Toon PSTF. Oh my god, we're going to see how that works in cycles too. But for now, let's see how it works in Eevee. For now, in Eevee, we can't visualize it by just viewing this. We can see it is like similar to the diffuse PSTF. If I take a diffuse PSTF, look at that. Let's compare this to this. It is so similar. I need just to put the same color. So we have this and this. So both of them are the same. These are the same, but they are not the same. Okay, they are not the same. They have this size, smoothness for both the glossy mode and the diffuse mode. Okay. And right now we can't see how this thing works. Okay, we need to visualize it using a shader RGB node. Basically, I'm mixing both of these, glossy and diffuse, converting that to shader RGB. Okay, basically I'm doing nothing, just turning that to RGB values or color data, and using the float curve from earlier, I can control the travel of the light, so I can make it sharp. As you can see, it's really sharp. And using the mix between this one and this one, I can change the look of that. Look at that. Look at that. It's so cool. I can make it in between like this. Look at that. And to add color, I can simply add it with a color ramp. Look at that. I can color from this to this. And Blender automatically will blend between them using the light intensity. Okay. This is super bright. This is medium brightness. This is dark. And based on that, it's going to map each stop. Okay, so the middle one is going to be in the middle, this one in the top is going to be this one, and the bottom, which is the black, because this float curve is going from 0 in here and 1 in there. So, and the color ramp 0 in here and black or 1 in here. Okay. And that's what gives us this color. Okay, you can change the color however you want, and that will change everything without changing the pattern of the Cel shader. Sometimes when you use the diffuse PSDF and using the shader and stuff like this, this pattern changes, okay? It flickers sometimes. So this one doesn't flicker and it works really well. And again, using the Fresnel to add some edge highlight. Look at that. It's super cool. It's super cool. And it's also, when I change the light, where's the light? If I change the light, it changes with the light, okay? It's interactive still, but it's not interactive with the light color, okay? Because as I said in the first step here, I want to control how the color should look like, how the cel shading should look like, okay? So this one is for control, and the other one is for interactivity. So cel shader with light, with color, stuff like this. Now moving on to the other one. This one is similar to this one, but with light interactivity. So I can still have color data and custom colors. I can set custom colors, and in the same time, I want the color that the light casts, okay? So using the same setup from earlier, which is Toon PSDF, mixing between them, shader to RGB, a color ramp. Instead of using the float curve, I'm just using color ramp straight away, okay? Which is really fast to compute than using float curve and color ramp after that. But still, it's not the best because you need to set the colors manually in here, okay? This is just another way to show you guys how this thing works. And because I want to implement the color of the light, I need the Toon BSDFs to contribute, because sometimes I want to make this a factor of 1, which is only this one is active, or value of 0, which is this one is active, or value of 1, which is this one is active. And if I choose only one, okay, with this shader to RGB, if I disable this one, okay, I never get the light or the color information because I only have this one is the active. So to get rid of that confusion, I'm just going to use both of them to contribute into color. Basically, this is a redundant thing because I'm using a value of 0.5. That means they're not going to add to each other because they will have or contain the same color data, okay, the same color, the same hex value. It's not going to change. It's not going to be brighter or dimmer or something like this. No, it's just a color information. So adding these together, okay, adding this color to this color, you might think that will add some values. No, it's not going to add some values because later I'm going to specify to the max color node to use only color values, okay? You can use saturation, you can use hue, but I want a color value, which is a contribution of hue and saturation, both of them, that will gives you color. Because if I do color, if I choose, like, for example, red is a contribution of this hue and this saturation. So that's why you need the color instead of taking only hue or only saturation. If I take only hue and no saturation, look at that, I'm back to white. So there's no point of using only hue or only saturation, okay? And the same thing, just adding Fresnel, just for visual interest, okay? So it's interesting to look at. And yeah, that looks good. That looks really good. Now, let's move on to the cycles ones, the ones that works with cycles, okay? So let's disable this and open up this. And for this to work, you need to switch to Cycles Render Engine. So let's go to the Render Engine and choose Cycles, okay? And you can enable denoiser if you want, so you can get rid of some noise, even though it's not going to be a lot of noise, okay? Just small amount, but let's make it clean. With YouTube compression, you'll never see the noise, okay? But yeah, just for me to see these things clearly. And right away, you can see that these are crazy. I have a new one, a new donut. This donut actually works in Eevee and Cycles. I'm going to show you later, but let's see these ones. These are the really interesting ones, okay? Let's start with this weird kind of donut, because this donut is actually interactive with the view angle. So if I see from this angle, I can see the light in this angle. If I see, okay, you can see. It is dependent on the refraction. You can use camera or window, but I'm using refraction for now. You can actually invert the effect with a scale matte node if you want to invert how this thing works, okay? Look at that. So I have the light in the view angle that I view, okay? Maybe it's kind of weird because it's limited kind of, but you can multiply this with whatever vector that you want, and it's going to be super bright. Okay, but for now I need it to be just the default. So I'm taking the refraction. Okay, let's mute this. I'm taking the refraction using color ramp to define some light intensities. So really dark, medium brightness, really bright. And after that, using the color from earlier, okay, I can contribute to all of these with the same color. You can use overlay, but overlay will make the brightest point really bright. Okay, if I use overlay, for example, where is the overlay? Look at that. This one is going to be really bright, and I don't want that. I want only colors. It's going to be a brighter color, but not really like white. I don't need white, so let's use color. Look at that. This is really interesting. It looks like a gold thing. And if I want this to not be really dark, I can just go back to color ramp, select the black slider, and just change it to whatever you want. And look at that. And that's how easy is it. And that's so easy to change. Really cool. Now let's move on to the really interesting one. This one and also this one. These both are really interesting. But let's talk about this one. This one, we have used the Toon PSDF. The Toon PSDF now, it should work. We should visualize it. It should work, okay? So now when I'm viewing this one with the mode glossy, you can see it's already glossy. You can see it. It's like kind of really shiny metallic something, okay? Because we have the smoothness. Basically, we are in the mode glossy, not the diffuse. The diffuse is going to be different, so you can see it's not glossy anymore. But this one looks glossy. You can see it has some ambient light, and yeah, it has some weird stuff. Basically, the size here control the size of this light, or how light is going to be contributing to this geometry. So right now it is kind of spread up, and low size means, yeah, low size, basically low size, and it's going to be really metallic. But for me, I like it to be kind of like in this, okay? And the smoothness basically make this light fall off smooth or sharp. Smooth looks like this, and sharp looks like this. Because we want cel shading, we're going to make the smoothness 0, okay? And for the other one, okay, with the mode diffuse, I'm using this one only to contribute to the color, okay, while still have some different colors, okay? So I'm using high size and high smoothness, so it is really smooth and also really big for the size and really smooth, okay? By mixing both of them, we can get both of effects working. I have glossiness and I have colors, and with that I can call it a day. That's it. It works, and it works really cool. And it is interactive with light, because I'm not using any shader to RGB because Cycles doesn't support that thing. So it's really cool. I can just change the color of the light. If I change the light, okay, select that light and go to the properties of the light, change it to, for example, red. You can see this one interact with it and it is red. Okay, so cool. Now let's move on to the other one. The other one is kind of simple, okay, but it is matte based. So as you can see, Cel Shader matte cycles. So this is based on matte. I'm going to explain to you really simply what I want with this. This one is kind of fake cel shading. What I mean by fake, I took the position of the light. Okay, let me enable the annotation tool. So basically, I'm taking the position of the light. So this is the light, and this is the donut. I'm taking the vector coordinates, which is the position. Like for example, 0, 1, 0. Okay, so it is 1 in the y-axis. Okay, so this is x, this is y, this is z. Okay, or you can, I'm just giving you an example. So I'm taking the position of the light, and based on how far this light from this object, we're going to create a gradient. So this gradient is going to go either from 0 to 1 or 1 to 0. Okay, it can be anything. Okay, so in this gradient, I'm going to kind of split it into multiple stages, and these stages are going to be super sharp, and that's what's going to create that cel shading. Maybe this one is going to be bright yellow, so bright yellow. This is medium brightness. This is kind of etc. etc. You understand, okay? And using that, I need also to contribute this with the normal, because I want to stick this gradient to each face. So basically, for example, this face, so this is how the donut or the torus looks like. So we have a bunch of faces. So this face is actually pointing this way, okay? So I need to map this gradient onto this face to create that cel shading. So how we can create that? Basically, just taking the normal of each face from the geometry, okay? From the geometry node, and using the dot product of this position, okay? And here I'm using two light because I have two lights in the scene. You can use more than one light, okay? And you can invert how they contribute to the gradient. This one is going from 0 to 1, and this one is going to the with the invert way, which is going from 1 to 0, okay? This one is going from 0 to 1, this one is going from 1 to 0, okay? Adding them together so I can have both of these gradient in the same time, and normalizing this vector, okay? Because I don't want any super negative values, but still we're going to get negative values because we are working with normal. Some normals is going to have negative values, or maybe this one is going to still have negative values. So basically I'm taking the product between the normal of the geometry and the positions of the light sources, okay? And we are going to map range them from whatever value to whatever value that we want. For example, from -1 to +1. I'm saying that maybe this dot product will introduce negative values. So I want to remove these negative values. So I'm going to map the dot product from -1 to +1, like I have -1 and +1 values, and mapping them to 1 to 0, like a 1 to 0 gradient. So 1 to 0, and based on that I can add colors, and that's what I did. I just used color ramp. You can see that I have added a multiply node and add matte node, okay? This one basically what it's doing is just adding some values to this, and these values are going to control the scale of each band or of each color, okay? Of each color strip. So these colors will be changed based on this matte node. So how big are they going to be? So let's see. This is basically how this thing works, okay? You can see it, okay? You can see. Based on that add matte node, I can change how big are they going to be. Look at that. So this is too big, this is too small. You can see. And in here, I'm just adding some color information because I want it to be interactive with light. So again, adding the diffuse color, or the diffuse, sorry, PSDF, and mixing it straight away. It's going to still add some bright values from the white color that I have added in here, but white is better than adding any other color, okay? So it's going to work kind of better. And you will see why I'm adding an RGB curve to the normal, because I want this light, okay, to be sharp. You can see this light, this colored light is sharp, but if I mute this, you can see it's turned to soft. I don't want that because this is a cel shading. I don't want it to be soft. So I'm just adding the RGB curve, okay, to the normal, and that will distort the normal in the PSDF, the diffuse PSDF. And that's it. Now I have both colored light and also controlled colors, okay? Super simple, super simple. The other one is simply the same thing. This one and this one, both of them are the same. Both of them are the same, yeah. I think that's it for all of these shaders. Yeah, I hope that it was super easy to understand. If it wasn't that easy, you can just go to my Discord server and just mention me and say, oh, I don't understand this part, and I can explain it to you right away in there. So yeah, thank you guys for watching, and please subscribe if you're not subscribed, and like and share this video with your friends.